Alright, time for another draftphysics.com video presentation. So, just an overview video. I guess it'll be a YouTube video. So, I've made a few videos, mostly on kinetic energy. I did do a photon video, but we'll skip that one. And, alright, it's been a week since Franklin Hu did his announcement that he concurs that there's something wrong with the kinetic energy formula. It doesn't even have a proper name. I mean, the whole confusion between kinetic energy and potential energy, when what should be said, okay, how it should be described is potential momentum. And then you'd understand that that's what gravity creates, is potential momentum. It's not potential energy. It's not energy. You're not in a state where you have any energy of any kind. You're not a battery when you're standing in gravity. You have to actually go through the process of allowing gravity to push you before you can have the potential energy converted, okay, into your actual energy. And it's really just converting actual energy, gravity, into actual energy, your motion. You consume the gravity, which ironically creates gravity because you're consuming the energy of the gravitational force by moving. Oh, it's all, it's all so simple, and they've made such a mess of it. So anyway, so Franklin, doesn't seem to realize that this formula is a little more important than just some, it's not an argument about nothing. Now, I would argue that clearly the kinetic energy formula has been absolutely useless in terms of human progress. It didn't invent the stagecoach or the airplane or the Model T or the computer or anything. It's absolutely useless as a formula. If you use it, you're not likely to get right answers. And so the only place it's really been used is in nuclear physics, particle physics. So they've measured the weight of the electron by measuring its velocity squared, okay, by understanding its whatever energy it has is a product of a squared velocity, which means you're obviously going to get the mass wrong. So if you squared the velocity to decide what the mass is, and you know it's going a certain, velocity, then you're not going to get the right mass number. So things like that, it's all over the place. Linear accelerators use it. All kinds of places use 1/2 mv squared to do particle physics, accelerator physics. And clearly all of the standard model theory, the quarks and all that kind of stuff, is based on this understanding of what an energy level is, that every time you convert big things into little things, you're making free energy. And on the particle physics level, it doesn't matter whether they make free energy. There's no consequence, because they're not going to make a nuclear, whatever, perpetual motion machine. So, but it just puts an awful lot of theoretical physics in big, big trouble if 1/2 mv squared isn't the truth. A lot of stuff breaks. And so he's not getting that part. So he thinks this is just some theoretical nothing subject when it's foundational to a gigantic hunk of what is called physics. So anyway, just throwing that in. So, the fact is, nobody's chimed in with anything called reasonable arguments. It's all quite disappointing. And it's the internet, and, it's now the obscure net, because anything that's not populist is invisible officially on the internet, pretty much. I mean, you just can't use a search engine to find anything that's not populist. And same in Google, but whatever. Alright, YouTube. So anyway, so this video, well, I guess we'll do first the counter argument is, and so I just present all these arguments and present them very well and blah blah blah, and they're just totally ignored, and that's really irritating. Hide the toggle. No, I don't want to do any of that stuff. I want you to do, what the hell is that? Isn't that bizarre? I guess that must have been the beginning of the video. Ah, that's why it did it. Okay, got it. So these are website videos, so I figure this is kind of a nicer view, and I probably should pause to do this part, so I will in future do that to save you the ugliness of it all. But anyway, and gee, there's no scroll bar, so that's a disadvantage there, isn't it? Oh, there must be one. No. Oh, come on. There's got to be one. I have to be able to scroll this. No, I can't jump ahead. Oh. Well, that's really disappointing.
That's right. So anyway.
Alright, so that didn't work. Alright, so I'll pause to figure out what I can do to make it work. Because apparently I can't do anything. Oh, it's really annoying. So unless I play a video all the way through, I'm sunk. Well, let me. Okay, yeah, I'll try that one after I pause. All right. Well, that didn't work. Yeah, you can just jump 5 seconds ahead at a time, and too much trouble. So we'll have to go with this format. It's a little uglier, but it'll do. So let's see what I'm saying.
Simple questions, and they.
Oh, I'll have to check the volume. It's always something. Oh, yeah, sorry, where was I? Yeah, I fell asleep. Yeah, I just was thinking the volume it's not the same, so it's not recording both sources, so it has to be loud enough for you to hear it in the microphone.
Won't do it. And so, yes, that would be part of the Deadpool, the science presenters on this medium.
Alright, so I was just pointing out how, in the past I did this contest, like who will fall first, like who will concede the argument that, yes, they made a mistake hundreds of years ago, this is a wrong idea, there is no squared velocity, it doesn't make any sense, blah, 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 blah. And it would just be interesting, in that context. Now, I'm quite certain it's going to happen, it has to happen, because the truth does win in the end, eventually. And so, people will have to deal with it, and but maybe it won't happen until 50 years from now. So who knows? And all of these players won't be players anymore. But it will be the context. It will be part of history. Okay, the people who just didn't pay any attention to the argument and just pretended their nonsense was the truth, and even though they didn't have evidence, they didn't have any good arguments they could present, they just kept making this stupid defense of this stupid faith-based fableism. 1/2 NV squared is a fable. It started as a fable, it was defended as a fable, it never had any integrity. And it's just a sad chapter in human dupery that people still believe. Sad, really.
Anyway, so, yes. So, this Ian Gosling comment just seemed so, it's like, okay, you're not really paying any attention at all, right? So you've been hanging around for 2 years in this conversation. You really haven't made a coherent response to anything I've said, in the sense you haven't explained how it makes any sense to have levers, and
I mean, again, how many times do I have to make the argument? Does anybody have any other understanding of a lever, okay, than a conversion device? That you take one form of mass and velocity, one big M, little v on one side, and you convert it into some other mv on the other side. That you're just converting momentum, and that it really doesn't destroy energy or create energy. That you'll use a little bit to the fulcrum, but otherwise it just converts one kind of amount of energy in a certain form into another amount of energy in a certain form. That is, a lot of atoms moving quickly, or very few atoms. Very few atoms moving quickly, or a lot of atoms moving slowly. And that's all it can do. It can take a 300-pound person going 10 miles an hour and make a 100-pound person going 30 miles an hour. That's what it does. It's a simple conversion device. It can't be a perpetual motion machine. It can't be a free energy machine. So that simple argument, they refuse to argue it. They won't give me any kind of glimmer that they have any explanation for how levers do something else. That they actually do destroy energy routinely and actually do create energy routinely. Because that's the consequence of 1/2 mv squared. 1/2 mv squared means anytime you convert a heavy thing going fast into a light thing, a heavy thing going slow into a light thing going fast, you make free energy. That's the consequence of the formula. Will they deal with that? No. And that's just what makes it also dishonest. All these people are so dishonest because they won't deal with the actual arguments I have made. It's just really disappointing that people are such liars. Eesh.
Cowards.
And cowards. They're such fucking cowards. Excuse my French, but I mean they're afraid of the word thing. You know, they're afraid of words, for fuck's sake. You know, they can't deal with reality on any terms. Yeah. Ugh, it's just pathetic. It's just so gross. Like I said, I really didn't think. I thought humans were kind of ugly and stupid animals, but I didn't think they were really gross. I mean, you're just looking like such hyenas. Like such a natural mistake.
Won't counter any of the arguments made in this video or any of the previous videos.
Yes, they just pay no attention. So I made the gun argument, the space argument, all these pressure arguments. I mean, the weight argument. It actually works, okay? You drop something from 4 times higher, it weighs twice as much. So I drop it this high, it'll weigh a certain amount. I drop it 4 times higher, it weighs twice as much. I mean, the giveaways are everywhere. People are just so damn stupid.
Because a guy who believed in solitons and monads put a square on.
So I've gone over the history. I mean, anybody who honestly looks at the history would have to concede there's no good arguments here. I mean, beyond the obvious ones, okay? I mean, Leibniz showed up, didn't present any evidence, just made the gravity argument. Just said, well, it's got to be 4 times the energy because it fell 4 times the distance. And yes, if you understood what that meant, was, yeah, but it falls 4 times the distance. 3/4 of the time it's falling 4 times the distance, it's going almost twice as fast. So of course, it's only in the gravity twice as long, and when it finally hits the ground, it's only going twice as fast. Those are really big twos, okay, that undoes that 4 thing. But that's the only reason why he threw this nonsense into the mix. And, back in Newton's day, the Newtonians, the people who defended Newton, made these simple lever arguments. They actually brought up levers and said, well, now you're making levers into free energy devices. Because you're not conserving momentum. And realistically, you're not conserving energy. Because momentum isn't energy by your definition. What the hell was that? Some kind of alien flying in front of me.
Do it like this. If I want to take half the.
No, so there I have it written down. 1, 2, 3, 4. Right, you drop 4 units in gravity, and it's only twice the amount of time, and it's only twice the velocity, and it's basically really easy to understand based on the inverse square law why this circumstance exists. But no, nobody will deal with those specific arguments.
Redone the experiment.
Alright, so I even point out how Stephen Bro's own experiment demonstrates it pretty clearly. Okay, he uses a lever, he puts a constant force on the lever, a constant amount of weight or pressure, then he puts a 2 mass and then a 1 mass, and he gets exactly what you would expect, which is pretty close to a 2-to-1 relationship in the velocities. I mean, damn it.
Okay, that this one is slowing down, this one will accelerate.
So again, this one decelerates. Whether I put a 2 mass here or I put a 1 mass out further, this decelerates at exactly the same rate. The 2 mass sees no difference. It slows down. It exchanges its pressure. It transfers its energy exactly at the same rate for both objects, because the lighter object, it's moving twice as fast. The half mass will go twice as fast. The full mass will go just 1 unit of velocity. Go the same it will accelerate at exactly the same rate as the other object is decelerating. So this one decelerates at exactly the same rate as this accelerates, which means like a Newton's cradle, you transfer all the energy. And because of the lever allows you to do the conversion to a half-mass object, because it will allow you to accelerate it at the necessary twice the velocity. So your acceleration will be twice as fast because it's twice as far out on the lever, and it will move twice as much distance in the same amount of time. I mean, there's a tiny bit of nuance to this argument, but it's just so obvious that that's how the physics is working. And there's absolutely no reason to think the half mass going twice the speed has twice as much energy, because it doesn't. It was created by the same force. It can't have twice as much energy. The force is the energy. I mean, damn. Wow. I mean, I marvel at just how corrupt and evil you fuckers are to sit there and pretend you have dealt in any way with these arguments. For 2 years you have ignored them and evaded them and just played games with words. F equals ma. That's not an answer. And it's certainly not Newtonian physics. Well, whatever. I mean, I just can't get past the distraction of the fact that there really isn't. I mean, yes, I have a pitifully small audience. There's not, but that none of the, 100 people, that it's really only 2 or 3 out of 100 that get it.
The contact isn't just exchanging. It's just this one saying, look, I'm +5 of something.
This argument is just so easy to understand. I mean, look, if I'm falling in gravity and I touch, say there's a wall and I'm falling by a brick wall and I touch the wall, what am I doing? I'm exchanging my motion with its motion. It could be moving up and I could be stationary, or I'm moving and it could be stationary. It doesn't matter. I'm making an exchange. And the exchange is I'm going to start doing what it's doing and it's going to start doing what I'm doing, and depending on mass. So obviously I'm not going to move the wall. All right, and obviously what's going to get torn is my finger, so there's lots of ways to know that I'm doing the moving, but regardless. The fact is my momentum is going to change because I'm going to start losing it. And it's the same thing that's happened to you when you're sitting down. You're just giving what gravity's still acting on you. You're still collecting gravitational momentum, but you're giving it right to the Earth. And then the Earth does push back to get rid of it, okay, because it rejects it. And you feel the pushback. I mean, it's so obvious.
And this surface is saying, well...
that's the end of the video. Pretty close to the end, so we'll just click one more.
About being logical. We don't care about being accountable and fair and...
I mean, yeah, integrity, accountability, fairness, these are all, concepts that anybody with a little tiny bit of intelligence should have some admiration for. And to find so many people where that is, they don't get that. Those aren't real English American words. No, they don't get that. It's pathetic. Scary pathetic. Alright, we'll go to another video. Alright, so this video I went over the math trick because it was kind of a good video that just goes through the process of this derivation, whatever you want to call it, where they convert a notion, an idea of something falling, okay, and it falls a certain rate. Or I could push something, and I could be accelerating it at a certain rate, 10 miles per second. And then they say per second, which doesn't make any sense because it's not per second. I mean, that rate is only for a period of time while you're falling, while I'm pushing. That's it. It's a number of seconds. It's not per second forever or something. So this whole squared thing really makes no difference. It's a nonsensical way of writing per second to write second squared. You're not squaring anything. You're not multiplying any number times itself. It's not a squared circumstance. You're falling in gravity a certain number of seconds. Yes, each second is 9.8, but you only fall for 2 seconds or 3 seconds or 15 seconds or 500 seconds. You fall a number of seconds, not a squared seconds. And this is how they fake, okay, an excuse to put this square in the math to justify 1/2 mv squared. It's just backward, reformulation to find a way of making it fit into the rest of mathematics. So they create a fake origin for the square, and this is the creation of the fake origin. They do something mathematically when they're treating acceleration that they don't do for any other equation. They don't solve the equation the same way. They solve it a different way. They use a different technique that allows them to create this squared seconds. They wouldn't do it with meters. Nobody would say, 5 meters per meter. Yeah, no. All right.
Lower than his initial speed.
Speed.
Okay, well, we'll jump ahead to the punchline-y part here.
Arbitrary second. Yeah, so and then he'll restate it again.
Negative.
So he's written the seconds, meters per second, over a second. So he's, instead of just solving this equation, so he has 5 into 3.5 meters per second. So 5 seconds into 3.5 meters per second. It's a solvable fraction. You just do the math, and you come up with an answer of 0.7 meters per second. You're done. You don't stick this little s down here in the bottom. There's absolutely no reason for there still to be a second down there. You already killed it when you did your division. It's already used. So they put it there so they have an excuse to recreate another fraction. And so they'll put the second over 1. So they can drag it into another equation so they can multiply the seconds times the seconds. It's really just such a horrid, disgusting, horrible, grotesque cheat. So I'll quickly draw it. I mean, it's really such a nothing thing that you should be able to get it. Okay, so something's falling. And the idea is it's falling at an increase in its acceleration. So even though it's falling distance-wise, 1 distance, 3 distances, 5 distances, right? At every unit of time, these are all just the same units. This is 1 time, 1 unit of time, 1 unit of time, 1 second, 1 second, 1 second. Now there's absolutely no reason, yes, it happens every second that you add this 9.8 meters per second, okay? So every second you add 9.8 to the speed, the velocity. Okay, so every second it gets 9.8 meters per second faster. All right, but there's only in this drawing 3 seconds. Right? What sense would it make for me to tell you it's going 9.8 meters per second? Well, I've already told you all you need to know. Per second means, okay, so every second it goes 9.8 meters. Why would I say per second again? Why would I square the seconds? Right? This isn't a squared seconds distance. This is 3. This isn't squared. And what am I squaring? 9.8? What's the sense in doing that? That doesn't make any sense. I square 9.8 and that makes this geometry make sense somehow? There's no sense to squaring a velocity. So it doesn't work. It doesn't make any sense. It's just a contrivance. It's purely contrived math. It's just to make the fable work. You have a gingerbread theory that houses are made out of gingerbread, and then you have to come up with some reason why they don't dissolve when it rains. That's all they're doing. They're just creating contrivances to make something nonsensible sensible. Why did it do that? Anyway, all the little things I have to relearn some of this stuff. Anyway, alright, so we'll play a little bit more of this, but I think you get the idea. That's all this is about. It's a gimmick. So he wrote it up here, okay, and he put seconds over 1. So he took this s down here and created another fraction. So now he created a more complex equation. So instead of making it simpler, he's made it more complicated. And they'd never do this with any other equation. So if this was meters divided by meters, they wouldn't do it. So it's just a fake, a fraud, a phony. It's just bullshit. And so then he cross multiplies and ends up with seconds squared.
Squared. And so just like...
So that was just gibberish, right? These are the units. That's what it is. Yep, that's what we do. Boop, 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 boop.
Yeah, so it wasn't at all rational. It wasn't something he does in other equations. It's just special math for acceleration. Special, phony, fake, fraud math.
Negative point. Then
I think I had a problem. This is, where my computer, the video card was crashing. So I don't think it's currently a problem. Hopefully not. Alright, so that's probably enough of that video. So we'll move on to the next one. Okay, I'm back. So this was something buggy. Physics is also buggy because I was just talking. I was a little buggy, it's a little, uncomfortable. Because this was the day after my video card failed, and so I had to resort to other means, which is working okay. I mean, half the stuff doesn't work anymore, but the half that does is good enough. So I might keep it this way for a while till I find a bargain. But anyway, so I was eventually just going through some of these simple arguments again. For what purpose, though, frankly? Because the audience is too dishonest and too stupid to engage in reasonable counter-argument.
They're connected to each other, so one, kind of substance is connected to another because they're sharing an electron or two or three. And so they're in a configuration.
Alright, so I was explaining why something like gasoline actually still does have potential momentum. Alright, so I'm just sort of describing how, yes, you can have atoms in a certain configuration, and you put them in a different configuration, they're going to fly apart. Pieces of the molecules are going to fly apart. Okay, the atoms don't break, but the pieces, the atoms are broken from being connected to each other to being disconnected, and they can do that with a great deal of velocity. And that substances like gasoline would be chemicals that once they start to fall apart, they hit each other with the pieces, and the pieces ignite the other pieces, and you have a chain reaction, a chemical chain reaction, where a lot of atoms fall apart very rapidly, and when that happens, it's basically an expansion of the space the pieces take up. It releases a lot of heat, but it's really releasing pressure. So just because some people think, oh, well, there's no momentum in a can of gasoline. Well, you can't see the momentum, but it's there. And it's there in the form of a bunch of compressed springs, a bunch of objects that are closer to each other and that closeness is dependent on stability. So if you break the arrangement, then you break the stability, and it all flies apart. Alright, so this was just going through the maybe hydrogen, oxygen kind of, why does that happen? Because in the form of the water molecule, the atoms are taking up much more space, and they've released some bits to go along with it, some heat. I'm still sort of talking about that and pointing out how the hydrogen is really it's not a hydrogen atoms that they have in the liquid hydrogen tank. It's, hydrogen 2. It's molecules of hydrogen where they're stuck to each other. The atoms are combined into little units, and it's those little units that are going to be broken in the process of converting the hydrogen into water, oxidizing it.
Electrons and protons that we're made out of, blah, 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 blah.
Alright, so I blah-blahed on that part when I finished, so let's see what the second subject
It'd be
was.
a great thing. But the fact that
Alright, so now I was making the friction argument about the, Franklin Who video, that frankly it is flawed video. because if he was getting this, there was two subjects he thought he was talking about. The one subject is 1/2 mv squared, and the other subject was he was questioning whether Galileo was correct that there's a 4-to-1 relationship to double velocity, that in gravity you have to go 4 times higher to get twice the velocity, and he was challenging that. And the fact that he was getting those results means there might be some question as to whether he was accurately measuring the actual velocity of the carts involved in his experiment. And that might not be a coincidence that he was getting this aberrant result. And it might just indicate that, yes, he did the experiment poorly.
Hours for something going 20 miles an hour, and I would.
Okay, so yes, I would argue that something going faster incurs less friction, and for lots of different little reasons, but that's a fact. And so anytime somebody's going to say that faster things have the same friction as slower things or heavier things, yeah, I'm going to disagree with that.
It was first proposed as an idea.
Alright, so I'm just pointing out how this goes back to the Leibniz thing, and the whole idea that there's twice the velocity means 4 times the energy. It doesn't show up in reality. It's not a fact. The Mythbusters video, blah blah blah, the lever's drawn down here. I mean, it's just not the truth, and it's pitiful that people won't admit that fact. And then I end with SpongeBob again.
The window, whatever it's called, the workspace. Ugh. Anyway,
yeah, so I will be making a Linux video, because I just want to talk about webcam access and all that kind of crap a little bit, and how you fix the properties on a webcam. So I'll throw that in here somewhere, so don't be surprised if there's a Linux video thrown in. Just because I did learn some stuff, and blah 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 blah. Alright, so we'll go to the next video. Alright, should be back. Alright, so this one I'm going over the Mythbusters video. And I do say something here that's a little dodgy, so I'll get to that. But I'm basically just explaining why, you can validate it. I got, a moron put up a comment saying they didn't drop it from the right height. And, they just keep making excuses to say the video wasn't done right, when it seems kind of, there's a substantial bit of evidence that can be gleaned by watching the video that it was in fact done right. And this little X right here can sort of show you part of that explanation. So I go through the whole arguments of, see, this, they measured from the top down for the angle instead of from the bottom up, and that's why it's written as 49 degrees. It's 49 degrees from the 90 degree straight line, that kind of thing. Blah, blah, blah. So, yes, it appears to be the wrong angle, but it's not the wrong angle, and clearly they go all the way up to parallel here. You can see that in the video. So let's see if I can just hit the right spot here to find the bit that I want. This is close. That's a little, okay, so here you can see it. So this is when they're going to have 2 of them swing. So they're both marked on both of these arcs, the 49 degrees from up here. And it's this distance plus to the middle of this piece of steel. So it's this distance here. And so you have to go this distance 1, 2, 3 times to get to the 90 degrees. And that's the point, that it's clearly very close, if not exactly correct. Blah, 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 blah. Alright, so instead I did from here, from the top of this, but this thing hits here in the middle, so that's where you have to measure from, is the actual distance that it's swinging on that arc. But that's the forward part of the hammer, so that's the little deceptive too, because the hammer does have an angle when it's coming down, so you really have to go with the center of mass line. I guess they should have done that. But regardless, it's pretty convincing. The cars demonstrate it, and it's just kind of irrefutable. So I'm pointing out in here, well, okay, I'll play this part.
This monstrosity, you know, that replaces Newton again. So it's opposing Newton, and they won't even, you know, their lies have gotten so thick, and there's so many.
Yeah, so yeah, I mean, it really is, it's really so offensive, you know, that they slander Newton with a formula he had. It wasn't his. He opposed it, overtly opposed it. I mean, Leibniz was, in fact, one of his worst enemies. By the time they were getting to be old men, they really did dislike each other quite intensely. And so he's taking, you're taking a theory proposed by the guy Newton really despised and saying it's his theory. I mean, that's really a slander. And they do it by saying F equals ma, which Newton didn't say. Okay, Newton basically said F equals momentum. And if you want to know your change in momentum, you want to know the rate at which your momentum is changing, well, then you do momentum divided by how many seconds. Not a big deal. You want to know the rate, you just divide by the number of seconds. But there's no v squared anywhere to be found. There's no seconds squared. There's none of that nonsense. That's not what Newton believed. Galileo, Descartes, and Newton all thought it's just about how much mass is moving how fast, period. That's it. Those two numbers is the whole story. There's no extra story. So I point out that yes, 4 times as high, twice the weight. I did the experiment. It works. Okay, so I point out the clay thing. I point out the 16-pound bowling ball versus the 8-pound bowling ball going twice as fast. You people are arguing that you're quite certain the 8-pound ball going 16 miles an hour has twice as much energy. Somehow it will do more work. It has more joules. Joules represent the capacity to do work in the world. That's why Joule did the experiments that got him famous. It's because he wanted to prove that energy does work, and that the only thing you're trying to do is prevent the waste of heat. You know, so you're trying to convert all of the heat into actual functional, purposeful, useful stuff. Minimize the amount of heat lost, because it's all the same stuff. It's the stuff that will make work happen. And clearly this goes with the whole thermodynamic argument that, you know, governs steam engines and all kinds of different things, where yes, you know exactly the fuel has to produce the energy of the heat plus the energy, the work you're going to find useful. And yeah, the physics is just, like I said, they had the right answer 350 years ago, and you know, it's just really sad, you know, that you backslid into fables and religion. So there's a lot more stuff drawn there. Let's just listen to a little bit of this.
I get 2 joules here and 2 joules here. I get 4. Same explosion. I get 4 joules versus 4,000.
So I was using the gun argument. You know, I put a gun inside of another gun. Okay, solid gun inside of another gun. Same explosion, and I fire it. The 2 guns are going to separate. I'll have 4 joules of energy. Same explosion, same amount of dynamite, right? Same amount of charge, and instead I put a bullet in the gun. Now I put 2 bullets in the gun, and I put the charge in between. So, you know, I have I just have a steel tube, you know, that's open in the center, and I have a little charge in the middle. So it's a gun that fires in 2 directions, right? It wouldn't be useful as a, you know, military device, because obviously you need to shoot yourself. So, you know, but clearly you could make one, you know, a double zip gun. And if I do that, I'll end up with 2 bullets that fly out, and I'll get 4,000 joules of energy. That's the truth. That's the implications of 1/2 mv squared, is that it says this preposterous thing, that somehow the same explosive could make 4,000 joules, or it could make 4 joules. No, it can't do that. Shit.
So that's good. So video card crashes and I survive it.
Ah, okay. So a little bit of that. Blah 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 blah. All right. So we'll see. I think that's the last video, but I'll make sure. All right. So I think that's enough of a video and such. So we go to the other Yeah, there, I can go there. Nice and quiet and clean. Anyway, yeah, so I think that's enough of a video. So till the next time and such, this has been another draftphysics.com video production, but there really isn't any, there's just, I can't buy an argument, can't pay people to actually construct a rational argument demonstrating how I'm wrong. All they can do is throw insults and do funny clown dances, buffoonery, and somehow they're pantomiming an argument. They're not making one. They're just pretending like they're making an argument. It's really so disconnected from the arguments I've actually made. Alright, so that's it. So we'll have to gracefully exit, which I don't have a graceful exit yet, so you'll just have to settle for this until I create some sort of graceful exit. So it'd be nice if I could just, well, I guess I can just slide this out of the picture and disappear into the oblivion and such.